Guys, I want to go through what we're going to be doing for today. So we're going to do some more practice with balancing chemical equations, and I want to make sure you guys have enough time to review for your test tomorrow, okay, or whenever the next day you guys have class. So when we talk about the chemical reactions and the balancing that we did, this question refers to those arrows, okay? So if you talk about seeing those arrows, every time you see one of those arrows, that's how you know there's been a chemical change. So when it says, what are the four basic different types of chemical reactions? As many coefficients as we want to add to an equation to make it balance out, there's still only four different ways that you can actually have a chemical reaction, the way the atoms interact with each other. The first one is synthesis, where basically you take two atoms that are separate and you make them combine. Decomposition is where you take two that are together and then you break them apart. So when it talks about single displacement, you can kind of tell by the pictures, you have two and then a one. And then after the chemical reaction, this one has bonded over here, and then you have another one all by itself. And then double replacement is basically where you have two, and they kind of like flip-flop after the chemical reaction and have a different partner, okay? So to answer this question, you can just basically say the four types of chemical reactions are, and then just list these four: synthesis, decomposition, single displacement, and then double displacement. So for today's assignment, I put it through Kami. I know some of you guys were having a little bit of issues with Google Draw and all that kind of stuff. So I want to just kind of break it down for you, make it a little bit maybe easier for some of you to put in the text boxes. All right. So this, when it comes back to trying to figure out how to do the balancing, just go back to these four steps. Okay. So the first thing, and I went through each four of these steps in the example problem. So first, determine the number of atoms of each element. Okay. So this is our example over here. So when you start your reactants, you only have one magnesium right here, but then you have two oxygen. And then for your products, you have one magnesium and one oxygen. So that's all you need to do, step one. Step two is pick the element that is not equal on both sides of the equation. So the oxygen is the one that's kind of out of whack. So step three, add a coefficient in front of the formula with that element to adjust your count. So it's always easier to start with the side that already has the compound stuck together, because then when the atoms are all by themselves on the reactant or the product side, it's always easier to add that coefficient to just a single element later on. So step three means you put a 2 right here. So then step four, continue adding coefficients to get the same number of atoms on each side. So for step number 4, if we just added a 2 here, we now have 2 magnesiums, which means you then have to put a coefficient in front of that other Mg on the other side. So over here for the example, you can just put in your text box that we're going to have 2 here. You're not going to put anything here, and then you're going to put another 2 over here. Okay, so then that way you should be able to count that you have 2. Oops, sorry about that. That you have 2. Where my text? That you have 2. There you go. Oxygen, and then on the other side that you have 2 magnesiums and then 2 oxygen, right, from that coefficient. So for the next, if you look down below, there's, click. My goodness. There we go. Then you have 2 oxygen. All right, so if you look down below at the practice ones, all right, so I'm going to kind of walk you through these. So if we start with the compound part, so the compound over here, you can kind of figure out, all right, I have 1 Ca, I have 2 oxygen, and then I have 1 Ca and 1 O. So I'm going to put in the boxes, and then I'm going to go back and change them, right? So I have a 1 here, and I have 2 here. So keep in mind, these are definitely going to have to change if they're not balanced. And then for the Ca, I have 1. And then for that oxygen, I also have 1. So if you look, you can tell you're not balanced. So right now, if I add a 2 right in front of here, that changes this to 2, and that changes that to 2. So now that side's okay. But if you look over here, something's still not right. So over here, we're going to have to change the number of CAs to make them equal. So I'm going to add a 2, and then that changes that count to 2. So as a final check, you can make sure I got 2 on my reactants and 2 on my products. I got 2 oxygen and then 2 oxygen. So down here for number 2, same thing. If you start by just counting what you start with, all right? So the box that I put in first is just going to be what we start with. So I have 2 N's and I have 2 H's. And then over here, if you remember counting these up, I have 1 nitrogen, and then for my H, I have 3, okay, because that little tiny 3. So now if you look, you can tell one of them is definitely out of whack. So I got 2 over here, and I have 3 over here. So if I just start by adding a 2 in front of here, because if you think about 3 and 2, the only way you can kind of get those numbers to equal out is by making 6, right? So you can take 2 times 3 and get 6, or you take 3 times 2 and get 6. So if I add 2 over here, that means I'm going to now change this number to a 2, and then this number has now become a 6. So now over here, for my H's, my N's are good, they're all evened out. So now for my H's, if I want to figure out how to get that 2 to a 6, all I have to do is put a 3 as my coefficient. So now, if I do 2 times 3, that gets me to 6, all right? So now for number 3, if you start by what you have to begin with, you have, for copper, you have 2 of them, and oxygen, you have 1, and then for carbon, you have 1. And then over here, for copper, you have 1. For oxygen, you have 2. And then for carbon, you have 1. Okay, so understand, I know it gets a little bit tricky sometimes if you end up looking at the number, like looking at the letters the same way they're kind of written, right? So usually when I'm writing down my letters, I keep them in the same order as the reactant side. And now if you look, things really aren't too balanced for this one. So we're going to start by looking at what we need to fix. So if you think about what we could fix or what we need to fix, the coppers are out of whack to begin with, okay? So if I have 2 here, that CU is all by itself, so I'm going to put a 2 in front of that and make that easy to solve, okay? So now my CU is equal. So now if you look at my oxygen, though, I have 1 here and I have 2 over here. So if I put a if I put a 2 in front of here, so now I have, this is going to change to a 4. And then now for my oxygen, I have 2. So now if you talk about being kind of uneven, now I got to go back. So now I have 4 of my copper. So now I'm going to change this to a 4 and that to a 4 because it's easy because it's all by itself, right? So now if you talk about the carbon that you have 1 on this side and then 1 on the reactant side, so you're good, all right? So you have 4, 2, and 1, and you're all balanced out. So now for this one, if you talk about taking, this is basically what happens to hydrogen peroxide when you like leave open the cap. So if you talk about what you actually are starting with, you have 2 hydrogens and 2 oxygens. And then over here, don't forget to count this little oxygen all by itself too. So you have 2 hydrogen, and then you have 1, 2, 3 altogether oxygens. So now if you talk about what's not even, as far as not being even, we're going to start with the hydrogen. So the hydrogen look nice and even, and the oxygen are what my issue is. Okay, so same thing. If you think about, if you have 3 and 2, 6 is usually the common number that they will both multiply into. So if you have 3 of those, So if you have 3 oxygen and we put a 2 in front of there, so now we're going to have 4 oxygen over here. And then you're going to have, so now you have 2, and then you have 4 oxygen on the other side. Hold on one second. Sorry about that. So now you have 4 hydrogen, and then now if you think about that 2, so you have 2 oxygen over here, and you have 2 oxygen over here. So that gives you a grand total of 4. Okay. So now it's kind of simple because if you just think about adding a 2 in the front here, now 2 times 2 over here will give you 4. And then on the other side, or I'm sorry, down below, you have 2 times 2, which also give you 4. Okay. So all together now, you have 4 H's and 4 O's, and you're good to go. All right. So for number 5, so I didn't put the letters down below, just because you can kind of add them in as you go. But for what we're starting with, so if you think about how much Na you have, you're starting out with one of those on this side, and then on the other side, little individual boxes. And then down below that, you also have Mg. So if you think about how many magnesium you only have one of those. And then down below for iron, you have 2 of those. Okay. So then on the other side, same thing, you're going to have the same 3 elements. So for Na, you still have 1. And then for iron, you have 1. And for magnesium, you have 1. So now if you think about what balancing you don't have here, so now the thing that's kind of messing you up is how many irons you have. So since you have more over here, we're going to start by putting a 2 right in the front of this, okay, because that's the one that we have to increase. So now if I put a 2 in front of there, this becomes a 2, and this becomes a 2. Now it's great that my irons are great, but now I have to change my sodiums. So that's kind of an easy fix, right? Because over here it's all by itself. So I can just put in a box that says 2, maybe move it over a little bit so you can actually see it. So now if I put a 2 there, I can change this to also say 2, maybe. All right. So now for numbers, so now we're all even out, right? We got 2. We have, sorry, I put them in the wrong order, but iron, we have 2 of them, and magnesium, we have 1 of them. So now for number 6, if you look at, again, and same thing, if you want to pause and like do it on your own and see how good you can do without my help, that's great. If you need my help to kind of keep going through it, that's also okay. So this one's a little bit tricky because I know the font kind of makes it look like the C and the L are 2 different things. They're actually stuck together, right? So that's why it's kind of easy. You have 1 of each. On the product side, though, magnesium, still have 1 of. Chlorine, well, let me make it the same as the other side. And I'm going to do H's. I have 2 of them. And then for my chlorine, I have 2 of them. Okay. So now, if you look at how uneven this is, we're going to start with our chlorines, right? So since we have more on this side, we're going to go up here, and I'm going to put a 2 right up top here, okay? So if I put a 2 in front of that, now I have 2 hydrogens, and I have 2 chlorines. Now if you look, we're all set. We have 1 and 1, 2 and 2, and 2 and 2, all right? So now for number 7, same thing, we're going to put in the letter Cl. Make sure that L is lowercase. We have 2 of those. And then for your K, you have 1 of them. And then for your I, for iodine, you have 1 of them. Okay. So then on the other side, I'm going to try to remember going in order this time. So your chlorine, you have 2, or you only have 1 of them over here. And then for your K, you only have 1 of them. And then for your I over on this side, you have 2. Okay. So now if your chlorine's good, your K is good, is your iodine that's a little bit of a pain. So over here, if I added 2, that might kind of solve some of my problems. So over here, if I have a 2, that becomes a 2, but then so does my K. So now I got to figure out, all right, what am I going to do to like finish balancing it out? So now if I have my K is the one that's an issue. So now if I add a 2 in front of here, I've solved this issue because now I have 2 here. And now for my chlorine, oops, now I have 2. There should have been 1 before, sorry about that. So now that's all evened out, okay? So now for my chlorine, I have 2. For my Ks, I have 2. And for my iodine, I have 2. And you're good to go. All right, so for number 8, so if you want to start with the elements that you have, right? So Na, you have 1 of them. And then for Cl, chlorine, you have 1 of them. And then on this side, your Na, you have 1 of them. You can probably tell your issue is your chlorine. Over here, you have 2 of them. So we got to figure out how to make this side also have 2. So if I put a 2 in over here, that's great because that now evens out my chlorine, but now I have 2 of these, or 2 sodiums. So now that I have a 2 there, I have to balance that out by putting a 2 up here. So if I put a 2 down, now that I put that 2 there, and now change it on that side. Okay, so now to make sure you're all balanced, make sure you have the same number of Na and the same number of Cl. And then for this one, so as you can tell, sodium is in a lot of chemical reactions, so is oxygen. So the fact that you're seeing these same elements kind of over and over again should probably help you remember which ones are a little bit more reactive than the other ones. And so my oxygen's over here, I only have 1 of them. So now, if you think about what you need to do to balance it out, over here you have 1 extra sodium than you need. And over here, I need another oxygen. So as far as what I'm going to start by adding, since I need more oxygen, I'm going to add a 2 right in front of this. Okay, so if I add a 2 there, though, that changes this into 4, and that changes that into 2. So I've solved my oxygen problem. Now I still have a sodium problem, which is kind of easy to fix because it's all by itself. So over here in front of the sodium, I can just put a coefficient of 4 and I'm all done. I can just say that I have 4 on this side, right? Easy peasy. So then the last one for sodium, and the last one in the example. So sodium over here, you got 1. Hydrogen, you have 1. And chlorine, you have 1. And then over on this side, I can say I start with 2 oops, let me start with the Na. So for the sodium, I have 1 of them. For the hydrogen, I have 2 of them. And then for the chlorine, I have 1 of them. So if you talk about how we're going to start by balancing them out, our sodium looks good right now. It's our hydrogen that's the issue. Okay. So for our hydrogen, since we have more on this side, I'm going to start by adding a 2 here. So if I add a 2 there, I have to change that to 2, and I also have to change my chlorine to 2, which now means you have an issue because now you have too many chlorines on this side. So over here, if you add a 2, now you've changed this to 2, and you change your sodium to 2. Now, hopefully you can figure out what the last step is, right? So we're almost there. All you got to do is add a 2 to that sodium on your reactant side, and then you're good to go, okay? So if you walk back through all the answers that we go through or went through, make sure that you give me the symbol for the element and how many numbers of atoms. And then when you're done, if you can just hit this turn in button for me, okay? So as a reminder, the rest of what I need to work on is a review. So for my in-person people, I don't know whether or not I was able, I'm recording this ahead of time. I don't know if I was able to have a live Kahoot with you or not. If not, my apologies. I hope you had enough practice on your own. And then for my hybrid people, make sure you go through those links to make sure that you can study on your own. And then today's closing question is brought to you by the test. So the test covers everything from this marking period, even simple machines, okay? So even something like a doorknob, you gotta remember all that kind of stuff. So As a reminder, I need you to make sure you study for your test. My in-person people, you're gonna have it on Thursday. My hybrid, you're gonna have it on Tuesday. Your review sheet, though, my in-person people, I need it by tonight at midnight, and then my hybrid people, you're gonna turn it in. I think it's due on Thursday or Friday. So for this closing question, it says, why is a doorknob a good example of a simple machine? So if you think about that action of turning it, that's a good example of a wheel and axle where you're putting in force to make the job easier. So to answer this, you can say a doorknob is a good example of a wheel and axle that allows you to increase the force added to the machine. So as always, if you have any questions, please feel free to email me. All right. Have a good day, and I'll talk to you guys later. Bye.